Well, welcome to the first part of Chapter 8. Chapter 8 has to do with one sample t-test, which is our first inferential statistic. One sample t-test can be broken up into two pieces. The first piece is going to be t-test to test the difference between row and zero, and then what's traditionally called the one sample t-test. And what are we doing when we're looking at t-test to test the difference between row and zero? We are going to find a sample correlation, and based on that sample correlation, we're going to try to make a statement about the overarching population. So that's t-test to test the difference between row and zero. Now when we talk about one sample t-test, which is going to be part 2 of this lecture and another video, we're going to focus on a sample mean, and we're going to test that sample mean against a hypothesized population value. Okay, so once again, we're going to use that sample mean to make a statement about the overarching population, which leads me back to my favorite way to start every single lecture. And I have a question for you. What are the two types of statistics? So we know the first type of statistics can be called descriptive statistics. And we can break descriptive statistics down into a couple pieces. In chapter 3, we talked about central tendency. Okay, so again, central tendency, mean, median, mode, Q1, Q2, box plot. So we have a bunch of those measures. The second type of descriptive statistics is going to be variability. So again, central tendency is going to help us figure out what the most frequent score is in a distribution of data, or what's said the most typical score in a distribution of data. Whereas variability is going to talk about the spread of the data. Okay. So the most simple index of variability is the range, and the interquartile range. But probably most important, we talked about the standard deviation. Okay, so what we also have going on here under descriptive statistics is we can throw in the concept of frequency. Right, and if you remember from our frequency lecture, which was chapter 2, frequency, gives us a rough understanding of central tendency and variability. But, with frequency, we did relative frequency, we did simple and grouped frequency. We did histograms and frequency polygons. We did bar charts for nominal and ordinal data. Okay. Well, we took it a little further, right? And I believe I mentioned this in my last video, but you can have univariate or one variable descriptive statistics. But you know what? I'm just going to throw that in here. And then you can have bivariate. I'm I'm probably going to throw that in as, let's see. So if you remember for bivariate, that's correlation, right? So that's describing the relationship between two variables, right? So variate means variable, bi means two. So there we looked at correlation, we looked at regression. Okay. So then what's the second type of statistics? The second type of statistics is going to be inferential statistics. And again, inferential statistics, very simple concept. We're trying to make a statement about the greater population based on sample data. Okay, so the rest of this course is going to be focused on inferential statistics, okay? So basically, there are different inferential statistics for different types of data. So for example, today, we're going to do t-test to test the difference between row and 0. Okay, and like I said at the beginning of this video, we're going to find the correlation of these data here. I'm actually going to give it to you. And that's going to represent our sample correlation. And then with that sample correlation, we're going to try to make a statement about the greater population relationship between these two variables. Okay? So there you have it. I'm going to go ahead and erase that side of the board, and then we're going to go ahead and start working on this t-test to test the difference between row and 0. Okay, so what are our variables? One variable is presence of meaning in life. Okay, high scores on this variable means that someone feels like their life is full of meaning. They have a presence of meaning in life. And then we have satisfaction with life. High scores on this variable means someone has, or means someone is highly satisfied with life. Okay. So let's see. I have the correlation between these two variables. Well, let me back up a little. So again, just for a little review, S1, S2, all the way down to S10. That stands for subject or participant. So we have 10 subjects taking the presence of meaning with life scale and the satisfaction with life scale. Okay? And then we're looking at the sample correlation between these two variables. And what you'll get is a sample correlation R equals 0.94. So let's go ahead and interpret that. Okay, so here is the interpretation of this correlation. Okay, there is a very large positive correlation between presence of meaning in life and satisfaction with life. So again, how do we get very large? Well, r equals 0.1 is small, r equals 0.3 is a medium correlation, r equals 0.5 is a large correlation. And again, these are plus or minus. Okay, and positive, it's not negative, it's a positive correlation. If it was negative, right, there'd be a negative sign. Now for this last part, it's explaining what a positive correlation looks like in terms of these two variables. Such that high presence of meaning in life tends to be associated with high satisfaction with life, and low presence of meaning in life tends to be associated with low satisfaction with life. So when it's a positive correlation, we have high with high and low with low. If it's a negative correlation, we have high with low and low with high. Okay. So this is our interpretation of the sample correlation between these two variables. Okay. So more specifically, when I say sample correlation, I mean the relationship between these two variables in this distribution of 10 participants. Okay. Good. I'm going to go ahead and I'm going to erase the correlation interpretation. And I'm also going to erase the data. We don't actually need it. I just wanted you to see where the correlation came from. Okay, so this is our first step in calculating t-test to test the difference between rho and 0. Okay, HO means the null hypothesis. So I'll write that in. HO means the null hypothesis. So the null hypothesis is rho equals 0. Okay? Rho represents the population correlation. Okay, so rho equals 0 is saying the population correlation between presence of meaning in life and satisfaction with life may be 0. Okay, retain it as one among many hypotheses that the data support. I'm not going to explain that for now, so just write it down. It'll come back later, but just write it down for now. And then we have H sub A. H sub A represents the alternative hypothesis. Okay, so rho does not equal 0. So when you have an equal sign with a slash down the center, it means not equal. So rho does not equal 0. The population correlation between presence of meaning in life and satisfaction with life is not equal to 0. So this is what we're doing when we're dealing with a sample correlation, right? And we're trying to make a statement about the population, okay? Your answer is either one of these, right? So based on our sample data, we can make the following statements about the population. Either rho equals 0, the population correlation between presence of meaning in life and satisfaction with life may be 0. And what does 0 mean in terms of correlation? It means no relationship. Or we can find that the population correlation between presence of meaning in life and satisfaction with life is not equal to 0. Well, if it's not equal to 0, 0 being no correlation or no relationship, then it means there is a relationship. So there's either not a relationship between these two variables in the population, or there is some sort of relationship between these two variables in the population. So the next step is we're going to select the alpha level. Well, this is easy because it's a given. For this class, it's always going to be alpha 0.05 two-tailed. Okay. And I'll talk about this more when I show you how to use the t-distribution to find the t-critical value. Step 3, we have to find the degrees of freedom. So DF stands for degrees of freedom. So degrees of freedom equals n pairs minus 2. Okay, well, n pairs, well, what does that mean? Well, if you remember the data that we just had on the board, there are 10 participants, and they had a presence of meaning in life score and a satisfaction with life score. 10 pairs, right? Participant 1, meaning, satisfaction. Participant 2, meaning, satisfaction. So n pairs, well, there's 10 pairs minus 2. 10 minus 2, we have 8 degrees of freedom. Okay, we're doing well. Let's keep on going. Step 4 is where we find our t-critical value. So I'm just writing t and then subscore critical. Okay. And what you need to find the t critical is you need the alpha level, which is a given at 0.05, and you need the degrees of freedom. Okay? So what this is going to look like is t critical alpha 0.05, 8 degrees of freedom. Okay, so now what we're going to do is we're going to use this information to pull up the t distribution on Canvas and essentially look up the t critical value. Okay, so in order to figure out what the t critical value is, you'll need to go ahead and log on to Canvas, our course of course, Files, and go to the folder called Tables, and you'll see the t distribution here. Oops. Here it is. Okay, so in this class, we're always going to use alpha 0.05 two-tailed test. And you'll notice, and later we're going to talk about this, it's in line with this idea of 95% confidence. So that's going to be something we'll talk about later, so it's going to make sense. Okay, so this is our alpha 0.05, and here are our degrees of freedom, right? So our alpha is 0.05, our degrees of freedom, 8. So we have to go all the way down to 8, and here is our critical value. It's 2.306. Okay, what if we had 4 degrees of freedom? What would our critical value be? Alpha 0.05, two-tailed test. And I said 4 degrees of freedom, so our critical value would be 2.776. Let's do one more example. What if our degrees of freedom were 500? Okay, alpha 0.05, two-tailed test. Let's try to find 500. Wait, the table only goes up to 120 or infinity. Okay, so if you run into this, you can either choose to use 120 or infinity. Okay, so degrees of freedom 500, well, you could either use 120 or infinity, so you're either using 1.98 or 1.96. Okay, so that's how you find the t critical. Okay, so we found out that the t critical value is going to be plus or minus 2.306. Okay. So now we get to draw a picture. Okay, we're going to draw a little curve here, and we're going to put our t critical. T critical is equal to negative 2.306. T critical, I'm just going to abbreviate it as crit. T crit equals 2.306. Okay, past the t critical in this direction, we're going to say P is less than 0.05. Reject the null hypothesis. Okay, and t critical off in this direction, P is less than 0.05, reject the null hypothesis. Okay, and then in between the t criticals, P is greater than 0.05, retain the null hypothesis. Okay. Cool. So I'm going to go ahead and erase the null and the alternative hypotheses. Okay, this is the equation for what's called the T obtained. So T, and then I'm going to write obtained. So all we need to do is fill in the blanks and calculate it. And once we have our T obtained, we're going to compare it to our T critical and see where it falls. We're going to see whether we reject the null hypothesis and interpret the alternative hypothesis or retain the alternative hypothesis. Okay, so R, we found that our R was 0.94. In my notes I add an extra decimal place, so I have it as 0.942, but it's very close. Shouldn't make much of a difference. Our N, again, N is how many pairs do we have or how many subjects do we have? And the answer is 10. 10 minus 2 divided by 1 minus 0.94 squared. I'm going to go ahead and grab my calculator. Okay, just so I can make sure everyone's doing this correctly. Okay, 0.94 squared is where we should start, and that's going to be 0.8836. So we have 1 minus 0.8836. Okay, so what you should find for the denominator of the equation is 0.1164. So 10 minus 2 is 8, divided by 0.1164. Okay, so before you take the square root, you should have 68.73. So we're going to take the square root of 68.73. Okay, and what we're going to get for this side of the equation in these parentheses is going to be 8.29 multiplied by 0.94. And what I'm getting is 7.79. Okay. And this is going to be slightly different from my notes. In my notes I have 7.94 just because when I was calculating it using my notes, I used infinite decimal places. Okay? And as you saw, as we were calculating here, well, except for here, I used 4 decimal places, but I pretty much just rounded to 2 decimal places, 2 decimal places, and the correlation's 2 decimal places. So, you know, as long as you're in the ballpark, that's fine. So on the assignments and on the exams, if you have one of these fancy calculators and you know how to save numbers and essentially keep infinite decimal places, go ahead and do that. Otherwise, just round to 2 decimal places, you know, for each analysis. Okay, so let me go ahead and write that down. So our T obtained is going to be equal, I think I said 7.79. That seems about right. Okay, so once you have your t obtained, you come back to the picture, right? So here's a t critical is negative 2.306, and then you have t critical of 2.306 over here. So it's like, think of like 0 being in the middle here. Okay, so now we need to figure out where our t obtained goes. Well, clearly our t obtained is going to be over here somewhere, right? T obtained, okay, is going to be equal to 7.79. So as you can see, our t obtained is in this region where it says p is less than 0.05, reject the null hypothesis. Okay? Okay, great. So now I'm going to go ahead and write the interpretation. Okay, so here's the basic interpretation, but there's a little more after this. So t obtained is equal to 7.79, which is greater than the t critical 2.306. Because it is possible that we'll have a negative number, I encourage students to use absolute value so you don't get confused by the number line. Sometimes it's weird to talk about negative numbers. So absolute value is this. So even if these numbers were negative, it would make them positive. Okay, so because the t obtained, okay, is in this rejection region, because it's greater than the t critical, our p is less than 0.05, Okay, and we're rejecting the null hypothesis. Okay, so when we reject the null hypothesis, there's only one hypothesis left, right? We only have two choices when we're doing inferential statistics. We're either going to reject the null hypothesis and interpret the alternative hypothesis, or we're going to retain the null hypothesis and interpret the null hypothesis. So we reject the null hypothesis, so we're going to interpret the alternative hypothesis. And all I'm doing here is I'm restating the alternative hypothesis. The population correlation between presence of meaning in life and satisfaction with life is not equal to 0. Okay, so it's not equal to 0. But then, okay, cool, it's not equal to 0, but then is it a negative relationship or a positive relationship? Specifically, there is a significant positive relationship between presence of meaning in life and satisfaction with life in the population. Okay? Significant positive relationship between these two variables in the population. Okay, the fact that we did t-test to test the difference between rho and 0 and we rejected the null hypothesis gives us the authority to say that there's a significant positive relationship. And how do you know it's positive? Well, we just go ahead and we look back at the sample correlation, which I forgot what it was, hold on, which is 0.94, and it's positive, okay? So there's a significant positive relationship between presence of meaning in life and satisfaction with life in the population. So in the population is key because that's the point of doing inferential statistics, right? This is our sample correlation, or the relationship between these two variables in our distribution of 10 subjects. But with inferential statistics, we could use our sample value to make a statement about the population. And that's what we did right here. So that's super important. Okay, so this is the interpretation, but now what I'm going to write is kind of like, how did we figure that out? What logic did we use? I think that's a better way of saying it. Oops. Started writing the wrong thing. This is actually the second statement. I'm going to go ahead and erase the rest of the board. It's kind of in my way. So I think we're good on that. Okay, ready? The probability of the actual data obtained. What was the actual data we obtained? We obtained a sample correlation. If the null hypothesis is true, the null hypothesis is saying that there is no relationship between these two variables in the population, rho equals 0, is less than 5%. So the probability of us getting the sample correlation that we got, if there's no correlation in the population, is less than 5%, right? So less than 5%, that's pretty small, right? So because of this small probability, p is less than 0.05 or 5%, it is concluded that the correlation of the population from which the sample correlation was drawn is probably not the correlation specified by the null hypothesis. And what that's saying is R did not occur by chance in a population where rho equals 0. Okay, this part's a little more difficult to understand, but I believe I can explain it well by drawing a picture. Oops, I misspelled which. Okay. So let's say we have this hypothetical population where rho equals 0. And why we're dealing in hypotheticals here is we don't actually know the population value for the relationship between satisfaction with life and meaning with life. We would have to collect data from, well, depending on how we define our population, but if we define it as the entire world, we would have to administer the presence of meaning in life scale and the satisfaction with life scale to like 7-8 billion people. So obviously we don't know that. We can just collect samples at a time. So hypothetically, if rho equals 0, meaning the relationship between these two variables in the population is 0, then the question is, what's the probability of getting the correlation, meaning the sample correlation that we got? Okay, so let's draw that up there. So we got a sample correlation that was a lot different from 0, right? So literally, the probability of getting the sample correlation that we got, if the relationship between the two variables in the population is 0, is going to be less than 5%. Let me get a red pen. P is less than 0.05. Okay? So that picture describes this first statement. The probability of the actual data obtained, which is our sample correlation, if the null hypothesis is true, this is saying that the null hypothesis is the population value, is less than 5%. Okay, cool. I think that's very understandable. Because of this small probability, it is concluded that the correlation of the population from which the sample correlation was drawn is probably not the correlation specified by the null hypothesis. Okay? This statement has to do with something called sampling error. Okay. So if we're sampling from a population, we can expect to get somewhere close or somewhere around the population value. So if the population correlation is actually 0, we would probably get, I don't know, we might get a sample correlation of negative 0.5, probably negative 0.05 rather, or 0.1, or 0.2. Do you see what I mean? So we would likely get sample values that kind of cluster pretty close to the population correlation. And this is called sampling error. Okay? Simply what sampling error is when we sample from the population, we're not going to get the exact population value, but we can expect to get, usually somewhere close to it. So the probability of getting these sample values that are clustering pretty close to the population value is P is greater than 0.05. greater than 5%, which we would consider a large probability. Okay. Because of the small probability, it is concluded that the correlation of the population from which the sample correlation was drawn is probably not the correlation specified by the null hypothesis. We're saying here, because we got a sample correlation of 0.94, and the probability of getting that if the population correlation is 0 is less than 5%, we conclude that the sample was drawn from a population where rho is not equal to 0. So it's more likely that maybe the population is over here where rho is equal to 0.7, right? And then if rho is equal to 0.7, we could conclude that r equals 0.94 probably happened due to sampling error. So the probability of getting it, if this was the population value, is greater than 5%. So another way of thinking of it is r did not occur by chance in a population where rho equals 0. So that's another way to say sampling error. All these values in blue that clustered around the null hypothesis happen due to chance, where r equals 0.94 didn't happen due to chance, okay? It happened because the population correlation is not equal to 0. We don't know what it is, but it's bigger. For example, it could be rho equals 0.7. Okay, so that's our interpretation for one sample t-test. And the cool thing about what we're doing from here on out, one sample t-test, independent samples t-test, dependent samples t-test, one-way ANOVA, repeated measures ANOVA, chi-squared, this interpretation is constant. We're using the same sort of logic throughout this segment on inferential statistics. So that's kind of cool. So write it down. You might not understand it fully, but as you spend time with the material, you redo the lecture, do the in-class activity, it's going to become a lot clearer to you. I'm going to go ahead and erase this. I'm going to focus on something now called confidence interval. Confidence interval is very powerful, okay? What we just did tells us that the population correlation is not equal to 0. It's somewhere off in the positive direction, but we're not sure. Confidence interval gives us an estimate. It gives us a lower bound and an upper bound of the population value. And you'll see as we do the interpretation, it'll become really clear. Okay, so there's our equation for the confidence interval. ZR plus or minus the t critical multiplied by 1 divided by the square root of n minus 3. Okay. So step 1, we need to transform R to ZR. So in order to transform R to ZR, you have to go to Canvas, Files, Tables, and pull up the R to ZR transformation tables. Okay? So let's go ahead and do that right now. Okay, so what we're going to do right now is we're going to go ahead and transform R to ZR. So to do that, you just need to go to Files, Tables, and you need to open up the ZR transformation table. Okay, so let's take a look at the ZR transformation table. So there's actually two pages. The first page is going to say R to ZR, which is what we're doing. The second page is going to say ZR to R, which is what we're going to be doing. So we have to transform R to ZR, do some calculations, and then transform ZR back to R. Okay, so here we are. Our correlation is 0.94. Okay, so the first digit's here, so 0.94. And then the third digit, well, in our notes, the third digit's 2, but we've been looking at the third digit as 0. So we'll do 0.940. So our ZR is going to be 1.738. So let's do another example. Let's say that our correlation was R equals 0.65. Okay, well, first digit is 0.6, second digit is 5. So 0.65, the ZR would be 0.775. Let's do one more example. What if our correlation is 0.03? Okay, the first digit is 0. The second digit is 3, so 0.03 is our ZR. Okay, so we transformed our R of 0.94 to ZR, and we found that it is 1.738. Okay? Let's go ahead and break this equation apart. It says plus or minus, but when we say plus, we're creating the UL, or the upper limit of the confidence interval. And what's our T critical? So we found our T critical to be 2.306. Okay, 1 divided by the square root of n minus 3. Well, n would be the number of participants, so 10 minus 3. Okay, so there we have our upper limit. Let me go ahead and erase the... Okay, so I accidentally erased the interpretation, and I was like, oops, shouldn't have done that. So I went ahead and I put it back up. So here's our equation, if you will, for the upper limit of our confidence interval. And now let's do the lower limit. Okay. Well, our correlation didn't change, or rather our ZR. So it's 1.738. The only difference between the upper limit and the lower limit is here. So lower limit you subtract, upper limit you add. Okay, perfect. So let me go ahead and grab my calculator and let's go ahead and do these analyses. So you're going to want to start over here with the square root, and you have 10 minus 3 is 7. So the square root of 7 is going to be 2.65. So 1 divided by 2.65 is going to be 0.38. Okay? So this is 0.38. And then multiply 0.38 times 2.306. Okay? And over here we're going to have plus 0.88. And that's for the upper limit, right? Plus, and for the lower limit, we're going to subtract 0.8. 0.88, because the right side of the equation is exactly the same. So then here we have 1.738 plus 0.88, and here we have 1.738 minus 0.88. So let's do that. 1.738 plus 0.88 is going to give us 2.681. .738 minus 0.88 is going to give us 0.858. Okay, so now at this point we just have to take those ZRs and we have to transform them back to R. So let's go back to the ZR transformation table. Okay, so we transformed R to ZR, and now we have some ZRs we need to transform back to R. So we go to this second table. Okay. Our first ZR that we need to transform is going to be 2.618. Okay, so 2.6, and the second digit, if we round, is going to be, so we'll say 2.62. So 2.6, and then the second digit is 0.2. So we'll just call it 0.99. Okay, and the other ZR we have to transform is 0.858, so we'll call it 0.86. 0.8 is the first digit, and 6 is the second digit. Okay, so as you can see, it's 0.696, or we can just call it 0.70. Okay, so that's how you transform your ZRs back to R. Okay. So when we transform 0.858, which is ZR, back to R, we get 0.70. When we transform our ZR of 2.618 back to R, we get 0.99. So the lower limit of our confidence interval is an R of 0.7, and our upper limit is an R of 0.99. Let me go ahead and erase this, and then I'm going to write the interpretation. Okay, so we're 95% confident, which is pretty confident, that the population correlation between presence of meaning in life and satisfaction with life is between 0.70 and 0.99. Okay, that makes a lot of sense based on our interpretation here. Okay. So something to point out about the confidence interval is go back to the null and alternative hypothesis. The null hypothesis is saying the population correlation may be 0. Well, according to our confidence interval, is our population, or can our population correlation be 0? No, because our population correlation is somewhere between 0.7 and 0.99. 0 is not included in the confidence interval, therefore we can reject the null hypothesis and interpret the alternative hypothesis. So see how these two things line up. I really like confidence interval. It just adds a lot more to this analysis, and it's really not much more work. Okay. So the last thing that I want to do is, here we rejected the null hypothesis, but what if we retain the null hypothesis? Okay. So let's say we did our t obtained and we found out that our t obtained was just 1. Okay. So now go back. I don't have it on the board anymore because I don't have that much room, but you remember that little graph where it had the t critical and then it had reject the null hypothesis, p is less than 0.05, reject the null hypothesis, p is less than 0.05, and then in the center it said p is greater than 0.05, retain the null hypothesis. Well, this t obtained of 1 would be right in the center there. We would retain the null hypothesis, p is greater than 0.05. Okay, so if our t obtained was 1, okay, and our t critical is the same, of course, p would be greater than 0.05, okay? Since p would be greater than 0.05, we would retain the null hypothesis. Retain the null hypothesis. So instead of interpreting the alternative hypothesis, we would interpret the null hypothesis, and we would say the population correlation between presence of meaning in life and satisfaction with life may be equal to 0. Specifically, there is not a significant positive relationship between presence of meaning in life and satisfaction with life in the population. Okay? So if you retain the null hypothesis, p is greater than 0.05, there is not a significant correlation. The probability of the actual data obtained if the null hypothesis is true is greater than 5%. Because of this large probability, okay, p is greater than 0.05, it is concluded that the correlation of the population from which the sample correlation was drawn may be the correlation specified by the null hypothesis, which is 0. And then here it would change to R occurred by chance in a population where rho equals 0. Okay, so that's what it would look like if you retain the null hypothesis. So we're done with t-test to test the difference between rho and 0. Next time, we're going to cover one sample t-test. Okay, let's go ahead and pray. Dear Heavenly Father, thank you for giving us the strength to, for me to teach, for my students to listen and to learn. Lord, we're so busy, but you have called us to this place, Lord. Thank you for giving us the wisdom to turn to you, to draw our power from you. For we know, Lord, that we can do all things through you. In Jesus' name we pray. Amen. All right. Well, it's always a pleasure. Feel free to email me if you have any questions. Have a nice evening.